Welcome back to another coding challenge video. Today we'll be doing the diagonal difference problem from HackerRank, and we'll be doing it in C#. So over here on the left we have our problem statement. I'll just go ahead and paraphrase it for you. Basically what we're going to be asked to do on this one is, given a square matrix of integer values from -100 to 100, we're going to calculate the sum of its diagonals and then compute the absolute difference of those sums. So looking at their example array right here, one diagonal is going to go from left to right, 159, and the other one is going to go from right to left, so 3, 5, and then 9. And since we're adding them, it doesn't matter if we go top down or bottom up. Either one will do, and because we're calculating the absolute difference, it doesn't matter which one we choose to subtract from the other. Okay, so jumping into this code, I think maybe one way of solving this that would probably come to your mind before any others, especially if you were a beginner getting into code, is you would probably make a nested for loop and inspect every single element in the array, determine if it's a diagonal value, and then add it to your diagonal sum. I think there's a better way that we can get this done, though, that will pretty much give us what we need by only inspecting each row and then calculating based on what row we are on, which column we need to look at in order to get both the left to right diagonal and the right to left diagonal. So let's start off by creating a sum for each of our diagonals. So we'll call one sum LR for left to right, initialize that to 0, and the other one we'll call sum RL for right to left, and we'll initialize that to 0. So the next step is to create our for loop, which will be in charge of going over every row. And if this doesn't make sense, don't worry, at the end of this video I'm going to be drawing a picture and showing you exactly what's going on here and why it works. So in order to get every row, we could really get this a number of ways, because we know that all of our rows and all of our columns have the same length. So we could get the length from really anything. I'm going to choose to just get it from the first row in array, and I'm actually going to put it up here because we'll need to use it in the loop, and I do not want to recalculate that every single time I iterate through the array. So we'll go ahead and just pull this out, and we'll name it length, and to access the first row we'll say ARR at 0.length. I am assuming that there's at least one thing in array. If array came in with 0 elements, this would throw an exception. There's not actually any constraints listed for n in the problem statement, but I think we will be just fine. So we'll go ahead and say use length, reference it in our for loop, and we'll just increment I by 1 after each iteration. So far what we've accomplished is a for loop that will go over each row. So while we're at each row, what we want to be doing inside of this for loop is figuring out our column value, which will give us the left to right diagonal value and the right to left diagonal value. So we'll start off with the easier of the two, which is the sum left to right, and we will add to that our diagonal value, which we will determine to be, first off, whatever row we are looking at, and here's the magic, the same index for the column. What we could do is we could add a 0 plus I, and then that kind of helps visualize that what we're doing is we're saying from the left side shift over however many we've gone down in number of rows. For the sum right to left, it's kind of the same idea. Whatever row we're on, we're going to want to start from the right and then shift left however many rows we have gone down. So we'll take advantage of length already being calculated for us, and we'll subtract I. Because C# is a zero-indexed language, however, length in this example would be 3. And if we try and access this array at 3 being a zero-indexed array, that will throw an exception. So we have to shift it by an additional 1 in order to get it to go from 0 to 2 rather than 1 to 3. Okay, and that is really all we're going to be doing. Apart from that, we'll just return the absolute value of our sums, the difference of our sums. And I'm just using the standard absolute value function found in the math library. So let's go ahead and run this code, make sure everything's going good, and then I'll go and draw a picture and kind of explain how we're calculating these array coordinates, I guess you could call them. So imagine, let me draw out an array here for example purposes. So I'll just have a two-dimensional array with just, I don't know, some random values in here. And to help you visualize this, let's also put the index values. So these are the index values for the columns. This is column 0, this is column 1, this is column 2, this is row 0, row 1, row 2. Okay, so just an example then, if we want to access something in array, say the first row and the second column, we'll say the first row, which is this one, and the second column. So we're going to be looking at this 1 value. Okay, so in the for loop, in the previous example, we know that I is going to start out as 0 and then gets incremented by 1 after each completed iteration. So we'll say 0 and then we'll go to 1 and then we'll go to 2. And in this example, that's all we'll go because 2 is less than 3, but 3 is not less than 3. So that's where it will end. So in calculating the left to right diagonal, we determined that we're just going to use I and then I. So this one's pretty easy to see. When I is 0, for the first diagonal value, we'll have array at 0, 0. So 0, 0 we can see corresponds to this. When I is 1, we'll be at 1 and 1, which will be that middle value, which is what we want. And then when I is 2, we'll have 2 and 2, and we'll be looking at this value. So you can see we're going on that diagonal right there. Perfect. So the little bit trickier one is the right to left diagonal, which we wrote as I and then length, which keep in mind is 3. And then we minus I and we will minus a 1. So when I is 0, we'll have array at 0 and then at 3 for the length, minus I, which is 0, and then minus 1. All of that is going to equal 2, and array 0 and 2 is going to give us 3. So that'll be 3. And then we'll do one more example here. So when I is equal to 1, we'll have array at 1, and then at 3 minus I, which is 1, and minus 1. This will all evaluate to 1. And so we will be left with array at 1, 1. You're probably confused why I draw my 1s different. So array at 1, 1 is going to be 0. I guess we should just finish it off. Array, get too crazy with those R's. So when I is 2, we'll have 3 minus 2 minus 1, which will be 0. So array at 2, 0, 2, 0, value 2. Perfect. That's all I have for this video. If you have a better way, please comment it below. We'd love to learn together. And that's all I have. Thanks for watching.